up with David here, and we'll have Larry go ahead and present. The computer that the main requirement we found was to have a large RAM buffer. So I have like
Right.
128 gigs of RAM, and we're basically using that as a place to store all of the last 5 to 8 minutes of IQ data, so that the program can go back, look at the last 5 minutes, and detect the chirps that it hears, and then do the processing
Right.
on it.
Yeah, he
So-
said that Alex said that he's got it running on 32 gigs on a NUC computer.
Okay, that's really good.
But that you really want 64 minimum and 128. I guess 32 minimum, 34 is good, 64 is good, and 128
Yeah,
is ideal.
Yeah,
we
the
never,
NUC has a limitation of 64.
Ah,
we
well,
never-
apparently
I
the
just
NUC
bought
will
one.
do it, but
30
hopefully
will
we
do,
can,
but 64 is the max.
right.
yeah,
Hopefully
we
we can come up with a low power processor to do it. And I presume the idea is to eventually get the FPGA to do a fair amount of the work.
Yeah, that would be really nice.
We're really not using FPGAs in USRPs, as far as I know.
Now, Tom McDermott looked at that a little bit, and he thinks that it is feasible for the FPGA to do it.
Yeah, we should continue to look at that.
Yeah.
I forget,
So-
is the USRP FPGA the same
Oh,
same manufacturer as what we're using for Tantrine, or is it the other guys?
that I'm not sure of.
I forget,
Yeah, I don't know.
but code is code.
Yes, it is.
If it's Verilog or whatever, it should transfer between platforms.
Right. Well,
Should.
it's all in, at this point, you know, the USRP is just being used for in the chirp sound, it's just being used as a A to D, as far
Oh.
as I know. So the code can be developed whenever for whatever. And if we do it transportable, that's probably a good idea.
Yes, I agree. All right. Well, I would like to welcome everyone to the Thursday, January 20th edition of the biweekly HamSCI Telecon. And we'll start off today with Larry Serra, who's going to be talking about his work looking at the enhanced 7 megahertz propagation between Japan and California on back in July, was it July 24th of 2011?
2010, and then I looked at every year after that too in July.
Great. So you can go ahead and take it away.
Okay, thank you. Good afternoon, gents. Larry N6NC here. Basically what happened is back in 2009, I had one of the first CW skimmers hooked up here, reporting to the reverse beacon network. And at the same time, I installed a 40-meter 2-element vertical array, very low angle, aimed right at Japan. I live about 700 yards from the Pacific Ocean here in San Diego. So I'd leave it, I had it set up so that every night from like 9 p.m. to 9 a.m., the skimmer would switch over to 40 meters because I wanted to see what the trans-Pacific traffic was like, call signs and so on. And it was fine for a year. There'd be a handful of overnight JA call signs. And then on this July 24th, 2010 date, which was a Saturday, I got up and looked at the recorded JA spots, and there were 141 of them instead of 3 or 4, which really surprised me. And it was between 0730 Zulu and 1430 Zulu, which was about midnight to, I don't know, 4 or 5 in the morning here, local time. It really puzzled me, and I made a note of it. And then I emailed you guys might know TAC, JE1CKA. He's a pretty well-known contester. And I asked him what was going on because of all these JA call signs. And by the way, that Saturday was not an international or US DX contest. There were no significant US domestic contests going on. And TAC told me that that weekend, every July, is the weekend of the Japanese domestic CW contest. So what those call signs were Japanese stations calling other Japanese stations around the islands and the outlying islands too. And I said, well, that's interesting. He said, well, the number's interesting, but also what's really interesting is 85% of those call signs were 5-watt stations. And this made it all the more intriguing to me. So anyway, I made a note of it. And then since we've been in lockdown for COVID, last August, I started looking into this in some more detail. First of all, there's no ionosons across the North Pacific anymore. So it's really hard. Fortunately, there are ionosons at Hokkaido that's run by Nagoya University, and there's one at Vandenberg Air Force Base, just north of Santa Barbara here in California. So after figuring out some of the, how the readout of the ionosons were, I checked the archives for that January 24th date, and what both ionosons at either end of the path reported actually a pretty good 3-hop 7 megahertz path from like Tokyo to Los Angeles. So I thought that was kind of interesting. I also looked at the RBN statistics. All their recorded spots are archived. Actually, I started back in 2009, the first year that I was hooked up to it. And there were not significant stations reporting then. So I went back and started at 2010 and then looked at July, the weekend of those Japanese domestic contests in July for a 12-year period from 2010 forward. And what I did was made tabular data of the high spot report dates on the West Coast, US. And then I have a degree from Scripps Oceanography. So I also went and checked the meteorological and wave height conditions for those dates. I also went back and used the VOA CAP software, which has a pretty good database from which it models. And it turns out that in the summer, anyway, in July, there historically was an 80 to 90% circuit reliability on 7 megahertz for the time of day that we were looking at. So I said, oh, that's interesting. I never expected that. But then I looked at the numbers and found out that there were certain dates where there was enhanced propagation on those dates. And I could show that by looking at the RBN reports of JA call signs on those days. I also went to the National Weather Service and looked into wind and wave charts, and also the 250 millibar and 500 millibar winds. Those are the jet stream winds, which the 6-meter E-skip guys had looked at, because if you get a switchback bend in the jet stream, that'll often cause a reflecting surface in the ionosphere. So I checked for all those things. There was none of that in the summertime, so that we got down to mainly looking at wave heights. N1DAY had written an article for CQ magazine a number of years ago, looking at 160-meter spots in Europe of US stations depending on statistical report of wave heights during those days. Basically, his article concluded that for wave heights under 9 meters, that's pretty big waves, that there was a 50% chance of having stronger US 160 meter spots reported from European skimmer stations and so forth. So anyway, that's kind of a hint that the lower the wave heights, maybe the better the receptions. So then I started looking at why meteorologically that might be a problem or might be enhanced by something happening over the Pacific. And basically, I've sailed the Pacific a lot in the Navy and as a racing sailor. And basically, the Pacific Ocean has 2 or 3 huge high pressure centers that form during the summer in July and August. It's the bane of racing sailors who do the Transpac race from Los Angeles to Hawaii, because you have to skirt the high pressure center to keep sailing by wind, because if you get too far into them, there's basically flat water and no wind. And then that's been reported numerous times by racing sailors. So anyway, that put me on to the hint that maybe this was flat water reflections. If you're looking at a 3-hop path across the Pacific. So I got with Carl, K9LA, who's kind of our propagation guru, and we started looking at it. And he did a prop lab ray trace model for 7 megahertz. And we had a 3-hop model that looked pretty good. And that I don't know if you guys can see this.
We can share it on. Can you share it on the screen?
No, I don't know how to do that.
Okay.
I've put it up in front of my camera. I don't know if you guys can see it, but that's the 3-hop 7 megahertz model. And I've tried to put in there for the date in question. The red ellipses are the general location of 2 big high pressure centers on that day, which happened to be, pretty close to the reflection points. Of course, what I learned is the RF waves refract in the atmosphere and reflect off the smooth ocean surface. And I looked into a couple of recent Chinese papers that suggested that for smooth sea reflections, there is basically a almost 6 decibel difference, lossless difference and speculative, what do they call them?
Specular?
Specular reflections off the ocean surface, which are basically like optical reflections off a mirror, angle of incidence equals angle of reflection. But with much less absorption from the sea surface. So now we were closing in on something. I tried to find, other than the National Weather, it turns out the National Weather Service, when they do their charts and reports of wave heights, they use as their data only the top 1/3 of wave heights, the highest wave heights, and then project that 48 hours forward. And mainly they're trying to be protective of mariners to let them know the worst case they might encounter with waves across the North Pacific on that date. So they're excluding 2/3 of data of wave heights in the way they report. So what we were looking for was kind of ground truth wave heights on the day in question, the specific day in July 2010. Of course, that's difficult, even though there are satellites now, they circle and you just maybe get strips of data information on wave heights. So one of my brilliant classmates from Scripps got the closest satellite data for that day and then integrated it to the points that we believe to be the reflection points that I just showed you on that chart. And basically showed that the wave heights for that day, in fact, as reported by the satellites, was 0.77 meters to 1 meter, with most of them around 1 meter or a little less than 1 meter. So anyway, we kind of zeroed in on that. Then I went back to VOA CAP and did its historical information, and it showed basically that for that date, meaning the date of the JA domestic contests in July, that there generally was very good smooth sea reflection, and that we had enhanced wave reflection, 3-hop wave reflection across the North Pacific in those time periods. Also, Gwyn Griffith looked at, he's a WSPR guy, he looked at that, and it showed some, at least for this past year, it showed some enhanced slots, time slots in July and in August. So that's an identifiable process. So basically, after we checked everything, virtually everything. In fact, I talked to Nathaniel about it, and besides 1 meter or less wave heights, the other variable seemed to be the KP index. And for the date in question, with the really good spots that my skimmer picked up, the KP was 1.7. And for the 12 years involved, it was never higher than 3. And of course, NOAA doesn't even suggest that there are geomagnetic storms from the KP influence for any number below, any number below 5 KP index. So I think that's probably irrelevant for the examination that we did here. So anyway, the one other thing we learned in this, though, too, is, while we evaluate Great Circle path, especially across the North Pacific, often the paths are not skewed. If any of you are contesters or DXers, you'll know sometimes you shift your beam and you'll have a much stronger signal off the nominal Great Circle direction. So not only is it not necessarily the pure Great Circle path, but also these big blobs of highs, which are sometimes 800 miles in width, have big areas where they butt up against each other that generally produce smooth seas, which in my conclusion produce the enhanced propagation, especially for those very weak JA signals. And that's about it. If anybody's got any questions, happy to answer.
Thanks a lot, Larry. Any questions?
Yeah, it's pretty clever. I just to clarify one thing. So you're suggesting that the skew paths as we see on these long DX QSOs may be a result of the ocean conditions. Is that right?
Yeah, the ocean conditions and other conditions of some kind of intense ionospheric density. The suggestion is that you just have to check. The Great Circle is not as reliable as I always thought it was. You know what I mean? And they said specifically in the North Pacific, in darkness, there are different things that happen. So you might be getting your refraction off another portion of the ionosphere off the Great Circle path. But any of those, no matter what, if you have a hop path that works, yes, the smoother the ocean, the stronger the signals are going to be.
Oh, wonderful. Thank you. That's why they call it radio sport, because the results are not predetermined. So this is great.
Exactly. Thank you.
Yeah, I thought it was a really neat little study. And I thought that was very nice how you were able to show the pressure systems and show how it's probably, more flat water there. And it looks like they really lucked out with the geomagnetic conditions too for that particular event.
Yeah, and they were also low for all 12 years. I think the highest it was for any of the 12 years in July for that weekend was three.
Yeah. Yeah, that looks-
So we should be able to see something similar across the Atlantic.
I don't know. I don't know the Atlantic. I mean, they suggested that in that N1DAY article, but 9 meters is pretty big sea. What N1DAY had was just kind of a statistical thing. And the most he could say from his statistical study was that there was a 50% chance of stronger reported American signals in Europe on 160 meters if the statistical wave heights for that period were less than 9 meters. But the Pacific, one of the things I guess I figured out is we learned this in 8th grade. The reason it's called the Pacific Ocean is because Magellan sailed it and got caught in those highs several times.
I guess we could look for other events that would have similar conditions, right?
Right. And probably the same study could be done over the Atlantic, I think, assuming, there's RBN records that go back. Frankly, it might be easier over the Atlantic because of the intense number of spots between the East Coast and Europe.
Yeah. If you don't mind, I can share on the screen the table you came up with of all
Sure.
the data.
Sure.
Great.
I can just put this one up too. I don't know if you all can see it, but
Yeah.
this is the NWS map.
I can show that too.
Okay,
I
good.
can,
Thank you.
yeah, I have your whole manuscript here. So let me change the view here one page. So I can start at I feel like I can start at the top and show the different figures you have.
Oh, I guess I didn't mention the interferometer. In the middle of this, I created a make-do interferometer with my recording digital oscilloscope that does calculations, and two active antennas, and did a whole bunch of tests, which are included as an appendix here. But basically, what I wanted to do was confirm that the VOA cap takeoff angles that are recorded. I started on the date in 2010, and that the takeoff angles were related to the elevation angles of arrival on the receive end of the path. And I talked to Carl K9LA about it. There's nothing that says that absolutely is connected, but my tests show that in fact, if you look at VOA cap reports in a column graph, the takeoff angles that reported the strongest signals at the transmitter end. And my reports on this end of the angles of elevation were within 0 to 2 degrees of the takeoff angles for those stations for that date and time reported by VOA cap. So that kind of convinced me that you should, if you have and it happened on the particular day that I think the takeoff angle in Japan was 8 degrees for 7 megahertz. It was reported as 8 and 10 degrees with the two highest signal strengths. And my 40-meter vertical array in EasyNet had a 10-degree elevation angle for maximum signal, and plus a dBi gain and stuff. So it convinced me pretty much that we had the right path across the Pacific for the study. I think it's above that. It's toward the beginning more.
That you're looking for.
Okay, that's the old one, right?
Right.
Okay, no, go. I think you can go a little further up there, maybe. Okay, down then. Sorry.
I don't think, are you talking about the same one that you showed us a picture of?
The National Weather Service chart. With the
Oh,
height
yeah,
on it.
yeah. That one. That one's here.
Yeah, that's it. And then if you can see that there's a barely visible yellow line that's kind of the great circle there. And then I've got two red dots that are theoretically the reflection off the surface points. Them's big highs.
Are those the highs that move with La Nina and El Nino? And would we be able to see that if this was?
No, that's different. That's different. That's at the equator. That's stuff that happens on the equator. This is definitely North Pacific.
Okay.
So how much do the two highs overlap if you're trying to sail through that and not get stuck?
Yeah, that's a good question. That in fact, that's the whole trick to winning the Trans-Pacific race.
Okay.
There's a guy named Stan Honey who's been a navigator on these for lots of different boats, and he's done quite an interesting study of it. And basically, you just have to, first of all, you got to know where the high is at that time, to the extent possible, and then skirt it. You do have wind further out on the edges and stuff, but if you, for instance, anybody knows when there's a high, you can get strong winds around it, but that's out at the margins and the fringes of it. But you have to determine how far out to get the wind you can be without lengthening your course path to slow, to make it a longer course and stuff. And that's the whole trick to the Trans-Pacific race.
So lots of experience.
Right, exactly.
Thank you.
Thank you.
In shorter time periods, you go through the same thing in air navigation. You make decisions about taking more northerly, usually more northerly or more southerly paths, depending on where high and low pressure cells are, to try to pick up tailwinds.
Right. It's the same thing. So, you're dealing with the wind that favors you.
And here's your data table.
Right. Okay, the first column's the year and the date. I did some research. The date's different. It's not the exact date because it's always a Saturday and it's after the IARU contest. And that tells you the dates. Now, the problem is we have a problem today, apparently, with the RBN. There are very few West Coast, especially Southern California, reporting stations. My pal Marco N5ZO just went online with a skimmer to report, but so there's very little data there. So I had to use several. Mine is N6NC. If you look at the stations on top there, Jack WA7LNW is in a very good position. He's at a Mile High station in a radio quiet zone in Utah. So he's one of the best Western area skimmers. Bob N6TV is in San Jose, and he keeps his skimmer up all the time. So he's got good reports. And then there were occasional reports from N6WIN and N6YX, and those two reports are added in that last column. And then the second one, the next column is yes, is were the Pacific highs present? Yes. And then the Great Circle Pacific wave heights from maps, NWS maps and satellites. That's the numbers you see there. And then I put in the solar flux index, the solar spot number, the A index, and the KP index.
So how far apart are WA7LNW and N6TV?
Well, he's in Utah, up in mountain Utah. N6TV is they're actually on about the same latitude, but they're probably maybe 500-600 miles apart. LNW and TV.
It's interesting because it's like when one's high, one's low.
I know.
Except for July 21st and moving July 21st and July 20th when they seem to be closer. So
right. And then to go look over here at the well, first of all, the K index is 1.7. Okay, it's pretty low. It's not as low as the next one or the next three actually. But I don't know I noticed that too, and I don't know what to attribute that to.
That's about the bottom of cycle 24, isn't it? Roughly at that time?
Yeah, it is. It is.
Are these zeros? Were you actually running your skimmer here, or did you stop it?
No, I stopped at I think 2014. I forget why, but I took it off in 2014.
Maybe you should change these numbers to be like
NA.
That's
so that
fine.
we know the difference between actual numbers and like, but you don't know. Do you know if these are also NAs or if they are just?
I don't know what those are. My guess is that Bob was offline for some reason.
Yeah, it would seem if you
Do you
have
want to change the zeros to NA?
Yeah, it would seem if you have zeros, they
It
would.
looks like there's no spots reported.
Yeah.
Yeah, he would think there'd be at least one.
But here, here you have it. You have one.
Yeah, the zeros are definitely offline.
Okay.
Yeah.
I will change those.
Okay. This 2018 seems to be particularly high compared to the rest of them.
It does.
Do you have any ideas why?
I don't. Other than the, well, let's see here.
The wave heights are 2 meters here compared to
Yep.
the 1 meter wave. So it's actually on the higher end of your wave.
And then look at the next entry for 2019. Wave height 0 to 0.5 meters.
Yeah.
And it's still not big spots.
No.
And good spots, but not extraordinary.
No.
Do they have on the Japanese side the number of logs that were filed for the contest?
No, I don't. I haven't asked that. I haven't asked that, but I did ask the guys that run the contest, and let's say they're not quite into the data detail that we are.
Do they even gather it?
Well, they must get the logs. I don't know.
Yeah, I mean, if they have where do they, what's the CQ or QST of Japan, where they would report those number of entries and stuff?
I think at least one or two of them are JARL, and but it's usually some guy that does it, some ham guy that does it, and they just had handed it off to somebody else.
Yeah, I've seen the guys at Dayton and stuff. Never asked about their magazine because I don't read Japanese. I don't even recognize it.
But I know a couple of the contesters, that's why I spoke to TAC when the first thing happened, when the 2010 thing happened. Yeah, that 2016 puzzles me, especially with the 2 meter wave height, but 2 meters ain't bad, frankly. You know, if you think about the statistical stuff in the Atlantic N1 DAY, the only thing he could say is wave heights under 9 meters, and that tells you about the Atlantic surface as opposed to the Pacific surface.
It'd be interesting if you could find some good examples that counter this too, where you do have a very high waves and you show low numbers.
Well, what I'd probably have to do is find, I mean, I suppose we could do it going the other way with our data, our RBN data. Yeah, but we don't report.
So have you considered, you know, the 160 meters and the higher waves, like a ratio between the wavelength of the signal and the roughness of the sea surface?
No,
It
but I'm
seems
not,
like-
I'm not that schooled in wave dynamics and mechanics. And I actually, there are some questions I had, first of all, about the direction of the waves, whether the waves occur orthogonal, right angle to the path, the great circle path, or whether the waves occur parallel to the path, the rolling waves, whether that affected the transmission, and nobody could answer that for me so far.
I mean, I was just thinking about it more in optical terms. If you
Yeah.
have a smooth surface, you're going to have a, you know, very specular reflection.
Right.
But if that surface is not as smooth compared to the, you know, wavelength of light, I think, but you're going to have something that's more diffuse and probably goes in more directions. So, you know, it could depend on where the reflection is and whether you want a smooth surface, ocean surface, or a more rough one if it's like off axis from, you know, as you say, when you can point your antenna in different directions depending upon some conditions, and that might be one of them, where, you know, specular reflection works if it's like right on the great circle route, but if the reflecting spot is off from that, then you might want something more diffuse reflection. Just an idea. But especially the 160 meters, 9, you know, versus 9, I'm sorry, 9 meter waves in Atlantic, was it 9 meters? I forget.
Yeah.
Anyway, yeah, so it seems like that ratio there looks like a smoother surface to the longer waves, and versus the 7, you know, the 40 meter and, you know, a couple meter waves in the Pacific. Just
Well,
a thought.
I'm sure there's an ideal waveform on the ocean and an ideal smoothness of the surface and an ideal orientation of the waves that would probably enhance signals, and that would vary by frequency, I'm sure. You know, a microwave dish or a dish antenna depends on frequency to get its maximum gain. And I would think the reflections, probably the most significant thing was the paper that said with a smooth sea reflection from the ocean, there was almost, it was 5.8 decibel. There was a reduction of 5.8 decibel absorption from the surface in a smooth sea. And Carl worked that out. And I footnote that in the paper. So that's sounding kind of optical to me.
Yeah, Yeah, exactly. And whether you would want to call that absorption of the sea or just a more, diffuse scattering of the waves of the energy instead of, a more perfect reflection.
Yeah. Yeah, right. It's probably not absorption. It's probably diffusion or something. Absorption happens up in the ionosphere layers, right?
Yeah, absorption would happen in the ionospheric layers. It would also happen when it hits the ground as well. You'd get some absorption there also. You're
The
not going to
ground
have
or water,
what's that?
the ground or water.
Probably. But
Not sure about that. I think
if you have a very, very conductive water, so you probably get much less absorption from the salt water than you would from, say, the ground.
like much, much less usually.
Yeah, because it's salt, very conductive water.
Yes, we've had, and a bunch of other contactors have had very good luck with vertical arrays, multi-element vertical arrays on salt water. We won the ARL DX contest as DX back in the 90s from Ensenada, Mexico, because we were on a sand spit between a saltwater lagoon and the Pacific Ocean. And basically there was salt water right underneath us in the sand spit, and we got out like crazy.
Well, I think this is really nice work, Larry.
Thank you. Well, it finally answered my question from 12 years ago.
That's really good. That's really good. Any more questions for Larry? Yeah. Well, thank you so much, Larry. I really appreciate you coming and talking today. And I hope everyone else appreciated it too.
Thank you.
Yeah. And I think it also gives us some ideas for doing some future investigations too, because I know I'd be very interested to know if this is repeatable. Can we show that this really does happen every time you have these particular conditions across the Pacific? Do you not get it when you don't have these conditions? Can you have a similar situation over the Atlantic? So I think there's a lot more work that can be done for future.
Yeah, I think particularly the Atlantic, I think there's probably a lot more data available too.
Do you know anything about, so it seems like in the Pacific, you always have those high pressure systems around that time of year. Do you know much about the Atlantic Ocean?
I don't know anything about the overall meteorology of the Atlantic. And actually, what I found is the Atlantic guys who try to do 6 meter E to ES to Europe and stuff know nothing about the Pacific either. So
yeah,
there's certainly a lot of low pressures that go across the Atlantic.
Right. And if half the guys in that article, if half the guys, if as low as he could get was 9 meters or lower, and that was only a 50% chance of better signal enhancement or spot reported, that right there tells me something about the surface of the Atlantic. I've sailed the Atlantic, and the North Atlantic, particularly in wintertime, is a very difficult place.
So Larry, I hope that you will consider also presenting this at the HamSCI workshop.
Sure.
Thank you. It would be a very good fit considering that this year's theme is the weather connection.
Oh, good.
So it would fit in our theme very nicely.
Will do.
Wonderful.
Thank you for your help and guidance.
You're welcome. So we still have a few minutes left. We had the Tonga volcano eruption earlier this week. And I know on the Monday night Tangerine Telecon, there was quite a bit of discussion about it. People are going to be looking in their grape data to see if they can see any signatures that might be from that explosion. I know the Dopplergram list has been having some discussion about it. And we think, I think the VLF people believe that they can see some signatures of it in the VLF data. I think the analysis I've seen so far is still fairly preliminary since it just happened, but I know people are looking at this. Does anyone here have anything they want to say about it?
For what it's worth, in Cleveland, John's data and mine match up pretty well for that day. On 10 megahertz, he has some interesting features. On 5 megahertz that are different. That's John's on 10. And my CHU data coming from the other direction are also interestingly different. There aren't as many stations recording CHU as WWV, but yeah, it's going to be really interesting to see if we can demonstrate a traveling wave.
So,
Yeah, the guy in the Netherlands had that same spike show up on his CHU measurements, which I thought was interesting.
What does that suggest?
That TID was really roaming around the world.
Yeah, it was many hours later in the Netherlands, right?
Yeah, I believe so.
So is there an electron bubble that blows out with the eruption?
no, I think it's mostly pressure waves that couple with the ionosphere. But here, I'm going to put a link in the chat. I haven't had a chance to read this yet, but some people on the Dopplergram list found this review paper. And it's in Reviews of Geophysics, and it is very nicely titled A Ionospheric Detection of Explosive Events. So if you want to read a nice paper about what to expect when you have an explosion on Earth and how that affects the ionosphere and how it can be detected, this is a good paper to read.
And it's downloadable.
It is. It's downloadable. I think it's available for free.
Yep.
What's the name again, or the DOI?
It's in the chat.
Oh, okay. Thank
If
you.
you just click the link in the chat, you'll get it.
Thank you.
You're welcome. So here's a schematic illustrating the ionospheric response to natural and man-made explosive events. Explosions on land are shown in the bottom left and earthquakes in the bottom center. Tsunamis due to earthquakes are shown in the ocean in the bottom right. So we've got, let's see. The surface and seismic waves on land are shown as concentric circles over land. The tsunami waves are shown as dark ripples on the screen. The disturbances generate shock and acoustic and gravity waves, which are illustrated as light circles propagating through the atmosphere. When the waves reach the ionosphere, they generate traveling ionospheric disturbances, shown as dark bands in the F region of the ionosphere. These perturb the signals from the GNSS satellite and galactic radio sources. The perturbations, illustrated by yellow zigzags, can be detected on the ground through GNSS receivers, high-frequency sounders, and radio telescopes. Remote detection of the waves generated in the conjugate hemisphere can be observed as well.
Question for you, Nathaniel, if we got a couple more minutes.
Sure.
Some of the chatter back and forth I saw, relating to the tsunami had to do with the total electron content. Is that also relevant to the discussion here?
Yes, absolutely. So total electron content is a measurement that's made by these GNSS receivers. GNSS stands for Global Navigation Satellite System. This is the generic name for GPS. So you're familiar with GPS. That's the United States' version of GNSS. But there's also a Chinese version and a Russian version. So the generic Yeah, GLONASS is Russian, Baidu is Chinese, and I think Galileo is EU. So what happens with total electron content is you have one of these GPS or GNSS satellites sending signals down to the Earth, and they're being sent down on two different frequencies. Typically, one's around like 1200 megahertz, the other one's around like 1500 megahertz. And those two frequencies are delayed by the ionosphere relative to each other. And that delay, that time delay, is a function of how many electrons the signal passes through as it goes from the top down to Earth. So a receiver on the ground that's listening to two different frequencies can calculate the delay, and then you can actually back out the total number of electrons between the receiver on the ground and the GPS on Earth, and the GNSS or GPS satellite in the sky. And that's what TEC, or total electron content, is.
So these, or the explosions, through what mechanism are they altering the TEC? Are they just compressing? Are they adding electrons? Is it spreading electrons out? Is it causing ionization from all that cool lightning that we saw in a lot of pictures?
I think the exact, like, there's probably a little bit of a combination of all of them, and the exact mechanism of how the waves travel through the ionosphere is still like up for debate. But I think the primary mechanism is going to be, you have collisions or compression. So you have the neutral atmosphere up here, and the changes in the neutral atmosphere, that's going to push the ionosphere around and cause the disturbances to be seen in the ionosphere.
But doesn't the lightning that you saw on that eruption, doesn't that suggest ionization?
Yeah, a lightning would, but I think this is, if you're looking at these periodic, if you're looking at periodic disturbances from the source, it's probably resulting from these waves.
Mhm.
I think too, the lighting would be quite a bit lower, obviously closer to the Earth's
Yeah.
surface than.
Mhm.
That's very helpful. Thank you.
Yeah, there's a paper I was showing on Monday night too. That was a GPS TEC paper of a tsunami back in, I think, 2011. Let me see if I can. Um, Here's this one. The 2009 Samoa and 2010 Chile tsunamis as observed in the ionosphere using GPS total electron content. Here, I'll put this link in the chat as well. And you should also be able to download this one for free.
Didn't even know there were tsunamis back then.
Okay, there's the other. I just put this link in the chat as well. And so, yeah, here they're using GPS to measure the total electron content. Do they have a map?
Nathaniel, you know, in my thing, I actually looked for total electron content from these GPS, but there was very little, none back in 2010 as far as archives. But I checked modern, and now with all the ships and boats and planes and everything, there's quite a bit across these paths, you know. And my guess is probably the Atlantic, the same thing.
Yeah. Okay, so here we're starting to see some maps: tsunami direction, TID direction. So you can see these, you can see a wavefront there, you can see a wavefront there. You can see these wavefronts in the total electron content measurements. So I guess if I were looking in the GRAPE data, what I would be looking for would be wave structures. I'd expect to see some sort of coherent wave structure that would move from, from where the tsunami occurred away from it, with a periodicity that would match the sorts of descriptions that you would see in these papers. Probably between 15 to 60 minutes. So we have a few people. I know Jim Farmer, he's trying to put together some GRAPE data looking at the tsunami event, or no, I'm sorry, not the volcano event and the associated tsunami. I think Jonathan Rizzo is going to put together a presentation regarding the VLF observations of this, and anyone else who wants to look at this is welcome to as well. So it looks like it could be very interesting. Well, that brings us to 4 o'clock today. Thanks for joining us, everybody.
Thank
Yeah,
you.
thanks everyone,
you.
especially you, Larry.
Thank you very
Great
much.
presentation.
Yeah, great presentation. Thank you.
Thank you.
Yeah,
Thank you.
thanks. That was good.
Adios.
Bye, everybody.
73, folks.
73.
73.